Good morning. My name is Nick Feimster. I'm a professor in the computer science department here at Princeton and the deputy director of the Center for IT Policy. I'm going to talk this morning about AI and how it intersects with the future of free expression online, including some of the technical and policy-related challenges that I see us facing in the coming years in this area. I will talk a little bit about my past work I didn't know that I was working on this, but I've been working on this for many years, and I'll talk about how that intersects with, I think, the future challenges. I'm going to start with some, what would seem to be easier problems and actually turn out to be hard technical problems, and I'll spend most of my time talking about things that I think are even harder. Okay, so when we think about control of online speech, I like to think about this in terms of two questions. Okay, one is who gets to speak? By and large, computer scientists, policymakers, others have really looked and focused on the question of the filtering and manipulation of internet protocols. I'm not going to talk about this today, but I wanted to just mention this because this is sort of where I got really excited about this topic, because there are groups such as Freedom on the Net that put out maps that look like this. And you'll be happy to know that as of 2016, we were still free. We're green. But then what got me thinking, particularly as a computer scientist and an empiricist, someone who likes to measure things, is that certainly we know from the political scientists that free expression in China is not the same across the entire country. It differs depending on whether you're in the cities, on the coasts, or perhaps in the western provinces. We also know that free expression varies by time. Political anniversaries, elections, etc., all affect these things. So I got really interested in that problem, and I spent a really long time working on how we can measure that. I'm not going to talk about that today. I'm instead going to talk about what I think is perhaps a harder related problem, which is who gets to be heard. Okay, whereas the first problem really is about measuring blocking and interference with internet protocols, this is really about filtering and manipulation that occurs on platforms. And by platforms, what I mean here are our social media platforms, search engines, news feeds, and so forth. I'm going to talk about three things here in the intersection with AI and various challenges. Personalization and filter bubbles, as well as attacks on those. Automated filtering, which at one point we thought was a good thing. It certainly turns out to be pretty complicated. And then finally, propaganda, and I'm not sure that entirely has to do with bots, but I will talk a little bit about that. Okay, so for those of you who haven't heard of the term filter bubble, that was coined in 2011. Eli Pariser wrote this book, How the New Personalized Web is Changing What We Read and How We Think. This came on the heels of Google starting to personalize its search results a couple of years prior to that. In short, just to quickly summarize the book for you, personalization creates this so-called filter bubble where I might see something that suits my own tastes, and you might see something that suits your own tastes as determined by your profile, things you've searched in the past, things you've clicked on, other sites you may have visited, who your friends are, movies you've watched, etc. Or perhaps better summarized by Mark Zuckerberg himself, a squirrel dying in front of your house may be more relevant right now than people dying in Africa. So if that doesn't convince you that we have a problem, I don't know what does. Personalization, as it turns out, it can also be exploited. Okay, let me tell you a couple things that we've done to try to wrap our heads around some of this and where I think some of the challenges continue to lie. So to the first problem, just the best case scenario in the absence of attack, one of the things that we did to try to understand this phenomenon was to actually execute search results from different places as different users with different histories. And we built a tool for that and released it. I won't summarize, I won't get into the details of all the results of that paper today, but I will tell you that basically the results are different. They differ a lot by geography and especially by profile. Depending on the search engine you use, you can actually move stuff around in people's search history, and I will show that in just a minute. We built a tool called Bobble that basically allows users to see what other results show up in other people's search feeds, search results, besides their own, to sort of help them understand some of these things. So in addition to search results for our esteemed department chair, Jen Rexford, I might get a certain set of results, but Baba would also tell me, hey, here are some other things that other people are seeing that you may not have seen. And by the way, here are the places in the world where those search results are coming up. This happens for news too. We actually built this tool and then we said, hey, well, what about news portals? Because that's a different thing. And I was just talking with someone right before this talk about this. It turns out that this shows up in news as well, and I've summarized a couple of the things we found here. What we did basically is take RSS feeds and we did named entity extraction on those articles, and then we piped those back into Google News Portal using the same kinds of techniques from different places around the world, hundreds of countries. And you can see some of those results here. There's the 80-20 effect showing up, as it does in many places. This I thought was pretty interesting, was that there were 8,000 queries we ran that returned a result in one country, but nothing in at least one other country. So there's a lot more to look at, I think, here, both in terms of search and in terms of news. Okay, so that's kind of the best case scenarios. We have these filter bubbles, but what about bad inputs? Okay, so let me just show you quickly. Personalization, has these caveats I mentioned, but as it turns out, it can also be exploited. What if I could put things into your search history? Well, that could never happen, right? Well, I'm about to show you right now that it actually can. This actually is a consequence of web insecurity. So we start searching by shoes. Now you can see here the search history is empty, except for my search. Okay. Now, what I'm going to show you here is that we're going down, we're looking for a search result, Macy's shoes. It seems to be not on the first page here. It's, I think, somewhere down towards the bottom of the second page. Okay, what we're going to do is move that. Okay. Next thing that happens, so that's on the second page. User goes to another site. Here's a beautiful picture of a muffin. Okay, great, lovely muffin, perfect. Nothing to see here, move along. Oh, wait, but when we go to the search history, now let's look. Oh, there's a whole bunch more stuff in there. Macy's shoes, Macy's women's shoes, Macy. What happened there? Well, how many people log out of Google? Okay, not many of you, I imagine. What I did there is use something called a cross-origin request to pollute the search history. And now when you search for shoes, there's Macy's shoes right there on the first page. So we were able to move things around, unbeknownst to the user, by exploiting some insecurities in the web. So to summarize, even in the best case scenario, I think we have things to worry about with regards to personalization. But also we have to think about what are the results of bad inputs to these algorithms, and what access might attackers have to pollute those inputs, and what effects might take place. Next thing I want to talk about is automated filtering. Okay, so as I mentioned, I've started working on this more than 10 years ago. Reducing unwanted traffic on the internet. We thought this was a good thing. And in fact, there was a conference or workshop on the topic, steps to reducing unwanted traffic on the internet. There's a lot of unwanted traffic. Let me tell you about that. One of them is spam, email spam. Okay, the idea here is that you've got good stuff, the ham, if you will, and the spam, and you want to distinguish those. There are different ways to do that. We spent a lot of time, looking at that. A lot of people had looked at, looking at the content of mails and things like that. We decided that actually we were going to apply AI to the problem of looking at network traffic and how mail is being sent, and figuring out if we can winnow out wheat from chaff in this domain. As it turns out, you can. This is the output of the rule fit classifier. It gives you nice, in this case, understandable results, ranked features of the types of things you can observe in network traffic that help you winnow out good email from spam. Okay, so AI is winning here. Okay, here's some results. We were pretty happy with this. Okay, here's our our confusion matrix, if you will. The 70%, that's our detection rate. We were like, yes, that's really good. That's as good as Spamhaus. Spamhaus is this really manual thing. It's slow. It's late to detect. We're getting stuff faster, ahead of time, all automated. This is great. There's this false positive rate. 0.44%, that sounds pretty good, right? Certainly good enough to get you published in the top tier security conference, except when you go to the email service providers and they're like, oh, wait a minute, that's 4 in 1,000 job interviews like going into someone's trash can. Oh, and by the way, not only is that a usability issue, that also turns out to be a First Amendment issue. We start getting speech complaints when we start trashing good emails. So that was my first intersection, back in 2009 of sort of AI and speech. It was like, oh, wait a minute. Filtering unwanted content, not quite as simple as it sounds. Needless to say, we plowed ahead like computer scientists often do. We did that. Then we basically figured out, hey, you can do this. You can apply this AI thing on detecting web-based malware on network traffic. That works. Oh, you can actually do it on this thing called bulletproof hosting, places where people host scam and phishing websites. You can do that by looking at applying machine learning to routing patterns. Oh, you can also even do it before the attack starts by looking at registration of domain names. Okay, so like 7 years go by, we're doing pretty well, right? We're winnowing out all this bad traffic, right? So we're good. Problem solved, right? Well, let me tell you a different story. There's this other project called PhotoDNA. It focuses on removing images of child exploitation that are identified in the NCMEC database. This is basically a database of known images of child exploitation. The way this works is sort of hash-based fingerprinting. Okay, so it's hash-based. You basically compute something on the image. It's smaller fingerprint, smaller representation of that. You compare that against the database of things that are known to be bad. If it's bad, you yank it down. Okay, that's not even machine learning, right? That's basically just simple fingerprint-based identification. Well, so we can do the whole spam thing. We can do all this attack traffic detection, et cetera. And this kind of thing basically can be done. We can take down child porn. So, well, what's next? Okay, well, fast forward to May 2017, and there was an interview with the inventor of PhotoDNA, who, I'm not going to play it for you now, but basically the summary here is that, okay, well, we got these other things we don't really like on the internet, terrorist speech, okay? Let's get rid of that too. And the quote in the interview is essentially, you can read some of it here, but essentially is like, well, actually, the tech companies know exactly how to do this, and they're just not working hard enough. They're not nerding hard enough. They're not paying attention to this problem. And by the way, like, not just terrorist speech, but we can take down, beheading videos, all this stuff. And by the way, this is not just, one person talking. This is Congress as well. There's a bill making its way through the Senate called the Stop Enabling Sex Traffickers Act of 2017, or SESTA. Sounds good, right? Okay, but then you sort of, and basically to summarize here, there's a law called the Communications Decency Act. Section 230 of that law basically indemnifies the intermediaries like Google, Facebook, YouTube, Twitter, et cetera, from being federally criminally liable for any content that users would post, such as perhaps this type of content. Okay, so the law is making its way through Congress. Most of the tech industry opposes it. Okay, scratching your head. Okay, let's look at who's in favor. Some people, Oracle. Oh, wait, the Motion Picture Association of America. They were actually one of the biggest proponents of this. So what's going on here? Well, I'll just say one thing, piracy, right? So there's a slope here. The idea basically, right, is that if we can do spam, if we can do DNS abuse, if we can do bulletproof hosting, if we can do the child exploitation in the NCMEC database, well, surely you can also do piracy, and you can also do other things we don't want, right? So recently, Cloudflare, right, a large content distribution network, decided, well, there's a lot of attack traffic coming from this anonymous communications protocol, often used for censorship circumvention, called Tor. Whether or not that's true or not is not something I'm going to take up. But the point here is that they just decided, well, we're going to block that. Okay. Well, it turns out that a lot of the websites that we visit every day are hosted on Cloudflare. So as a result of that, a lot of people who rely on Tor to access the internet can no longer can no longer access those sites. Okay, so just to go back 1 minute, one of the things that might happen here, right, if these types of things get required, a natural tendency would be, let's use automated filtering algorithms to implement them. Let's use AI to basically implement that automated takedown. After all, we already know how to do it, right? And by the way, the internet, right? There was a quote many years ago that the internet recognizes censorship as a failure and routes around it. I think that's basically completely false. A better version of that quote, which I think I've encountered a lot in my measurement work, is internet censorship can be made to look like failure, and often does, right? So outages, et cetera. How do you distinguish that from censorship? But that initial quote is becoming increasingly less true, and the deployment of automated algorithms, right, to do takedown, et cetera, there's going to be an even bigger lever, which is the centralization of content, right, on a few CDNs, a few social media platforms, a couple search engines, right? And once these decisions get made about who gets to be heard, what gets to be taken down, it's going to be pretty easy, actually, to pull levers in certain places, just like happened with Cloudflare. Another recent example was the Daily Stormer, a neo-Nazi propaganda website. Now, regardless of what you think about that type of content, and I think probably all of us agree about that, Daily Stormer Cloudflare decided that that wasn't good either. Okay, and they decided we're basically going to take that down as well. Post is very interesting. They talk about all the different places where you can pull a lever on the internet to stop unwanted content or unwanted speech, not just the content provider. And by the way, a lot of these things, from content creators, platforms, ISPs, DNS providers, do or can use automated algorithms to make decisions about whether or not they're going to allow that content to be hosted, whether or not they're going to allow that domain name to be registered, whether or not they're going to deploy an access control rule in their firewall to stop that content. Okay, but the general problem is, to conclude on this, is a lot harder than spam, phishing, and child porn. In particular, I think we've got a long way to go with automated algorithms. Child porn, presumably you know that when you see it. Spam, phishing, et cetera, a little bit harder, but generally we can identify those things. As opposed to, say, a database of known images or of copyrighted images or sexual exploitation images, offending content in terrorist speech, hate speech, et cetera, this stuff is infinite, right? You can't build a database and hash everything and compare against known images. Context is absent, right? So even if you could design an algorithm to recognize an assault rifle, which apparently can't be done, or an ISIS flag, how do you know it wasn't parody, right? Fair use, right? Easy enough to identify something, some piece of content that violates copyright, but how do you know that basically it isn't being used in a way that's okay? Finally, I want to talk about propaganda quickly. Okay, so this is a story from yesterday, actually. I don't know if people have been following the Catalonian secession or independence developments, but one paragraph from this article relates to today's topic, which was there's basically the use of mysterious social media bots and Russian-sponsored media outlets to in effect to sort of influence opinion here. Now it turns out, actually, so this is 2017, we actually looked at some of this back in 2012 with Professor at Georgia Tech, Hans Klein. We thought, okay, let's see if we can detect propaganda on Twitter. Now, what the heck is propaganda? Can we even define it? Not sure. The way that we defined it is actually, I won't get into the details of it, but I don't think it will work anymore, because it relied on looking at Twitter usernames and handles that followed one side of a debate or another. So if we look at a Senate race, you could take the Republican and the Democrat and say, oh, the people are following the Democrat, clearly aligned with that side. Well, now we've got trolling and bots and all kinds of things that probably violate that, at least as far as the follower graph is concerned. Needless to say, we found some things, right, that presumably need to be reevaluated now. But one could ostensibly think about, rather than just looking at the content of what's being said or the images or what have you, maybe we can look at properties of the posting patterns or properties of the accounts that are posting, such as how long they've been around, et cetera, et cetera. What does this have to, so broader question there being, what do we even do about this? I gave a variant of this talk yesterday and someone said, what is the desired outcome? And I'm not entirely sure, so I'm going to close with some thoughts on that. But maybe we can at least identify some of this. What are we trying to identify? Is it bots? Well, maybe not. Okay, this is a picture of the Chinese 50-cent army, and Molly Roberts and Gary King, political scientists, recently wrote a paper about this. But essentially, there are large armies of people in China that are posting on social media trying to affect public opinion. So we could talk about, oh, let's just detect automated things. Well, what's the difference between scripts that automatically pounce on a political tweet and a room full of people doing the same thing? So maybe it's not all about bots. Okay, so finally closing. I think we've got many challenges to look at, some technical, some policy related, right? So understanding what's possible, I think, remain important open questions here. Mitigating bad inputs to personalization, understanding how those affect personalization is an example of that. I think hopefully my talk illustrated there are a lot of open questions as far as what's even possible with automated filtering. One of the policy debates that I hear a lot in Washington is that automated filtering or automation in general is just creating bad outcomes. Well, we've seen examples where it can create good outcomes, right? There's certain kinds of things like phishing, spam, scams that we definitely don't want. I think this basically bears further exploration. What are we good at detecting? Maybe we can detect spam really well. Maybe we're good at detecting hate speech and it's much harder to detect other kinds of speech. I don't know. On the policy side, I think all of this can inform and should inform the discussion about what should be required of content providers, of platforms and intermediaries, et cetera. And I think we have to be engaged here and we have to bring the technical perspective to this debate because somebody is going to decide, perhaps for us, if we don't actually participate in this. So last slide. I think continuing to push the boundaries of technical solutions in this area of automated algorithms, its intersection with speech, really important. And I think as computer scientists, we're very good at this. And I think this second point, I think we certainly have a lot of work to do here. And I think with the initiative that's starting here at CITP, we have a lot of opportunities to explain and understand the limits and the potential of these technologies to those who are making decisions, who rely on these automated algorithms. Thank you.